Good afternoon, everybody. Thank you for coming out. So Mahoney, we're going to start. Does anybody, before we do start, does anybody know what 3D printing entails as it relates to construction? Anybody in the crowd? So I'm going to, I'm going to show a quick video, which will pretty much detail the inception of 3D concrete printing. And this was done in the early 1940s. So 3D printing has been around for quite some time. It just hasn't been perfected as of yet until the late 2000s. We're going to go to the next video. And this is what it looks like now in the actual factory. This is how we look to build and bring the next iteration of development to real-world uses. As you can see, this is all printed in a factory, layer by layer. And this was done over the course of about a week and a half. And it pretty much shows you all of the detail from the ground up to the actual finish that you'll be able to see. Typically, when you're printing and you're using a 3D printer, it's layer by layer, so the actual walls won't be as smooth as the finish, but starting out is kind of corrugated a little bit. But as you can see, as we go along through the process in a very controlled environment, you can see how quickly you would be able to build and how efficiently you'll be able to build differently than you would traditionally, whereas there would be a lot of waste, a lot of extra form work, and things of that nature here. So I just wanted to give the audience just an overall view of what the actual process looks like. And of course, afterwards, we'll have questions that you can ask as well. But this is your next iteration of how homes will be built and what they would look like. Architects will be free to build whatever they envision in their mind, whereas today, it's a little bit different. You're kind of restrained with what you can build, but these builds are seismic proof, hurricane proof, tornado proof, pest retardant, fire retardant, a lot different from the things that are going on in today's society. So seeing as though we're in 2026, we kind of act like we have the technology and apply it to what's going on now. I don't feel like it's a good thing to be able to charge young individuals $400,000 to $500,000 for a home that has been built in 1970, when we can actually have a new home that's built that will be more resilient, slightly a little bit more affordable as well, because we won't have a lot of excess. So it's just bringing the times to today's actual development. And I think we'll be able to do that and mainstream it as we go along. So with that being said, we're just going to start the presentation. Again, I just wanted to give you guys an overall view. And I decided to bring my partner, Islam, today to interview me to pretty much have some good feedback for you guys. I just didn't want to memorize a whole bunch of things in my head and then regurgitate something and then give it a presentation. I kind of wanted to have a real-world experience. This is something new. So at any point in time, anyone has any questions and you don't understand something, just raise your hand and I'll go back and we'll be able to go through the whole entire process. Is that okay with you guys? Cool, let's have some fun. Let's go.
First question, what is Fordham Enterprise?
So Fordham Enterprises is a company that I started right after COVID. I was working with auction.com at the time, and that's in the real estate world, and I was actually in charge of selling off their inventory for the homes that would be in foreclosure. And once that actually stopped, we weren't allowed to do anything. And throughout that process of development, I always understood that building would be the biggest barrier that we would have as it relates to lending. So Fordham Enterprises came about out of necessity and also laziness as well. Sometimes laziness can inspire you. I've always wanted to build homes. I just didn't want to do the work. So I wanted to work smarter and not harder. And I decided to form Fordham Enterprises to bring the next iteration of lending and also development together, so that way we can streamline the actual development process. So that's how Fordham Enterprises came about. Not only do we build, we lend for commercial and residential projects as well.
So I know that you mentioned that, but can you iterate more on 3D printing? Like how did you start interest in it, and
Oh,
when was that? And
So that came about, so again, with the housing process. I used to be a fixer and flipper, and sometimes when I would drive past the actual homes being worked on, I would see a lot of my workers that I was paying daily just sitting down doing it, nothing. So I started to think about what is the best way to build more efficiently, more faster. So I started to do a deep dive and do a lot of research, only to find out that 3D printing has been going on since 1940, and it was totally new to me at the time. So with that being said, I tried to figure out what other companies were actually in this space at this time and pushing the metric forward. And I was fortunate enough to talk to Icon, who was doing a lot of development and work at the time. And with looking at what they were able to do in the machinery, I never was able to look back. I mean, they were able to build a lot of resilient homes. They had the science and everything behind them. And with looking at all of the technology that was coming forward with it, I just set in my mind that this would be the next wave to build. So it's been a long, deep dive since that. And it's actually put me in a situation where I'm able to talk to a lot of developers. What we're trying to do, we're not trying to put people out of work. We're trying to have them work alongside the machine. And to see so much synergy in the industry to bring these thoughts and actually these working standards forward, it was just the best thing to do. And at that point, that's when I pretty much pivoted from lending and all of the other aspects and just started focusing on 3D printing.
that's great. So this is just an introduction here. Last question here will be, how does you see construction through the lens of capital, community, technology change, and that question we ask about how city will be built in future?
So I'm not sure, how many of you heard of smart cities? Anybody heard of smart cities? Okay, 1, 2. So as with the question that Islam just asked, he asked how does capital development and also city planning come together? Well, capital is the first part. You're only going to go as far as the money that you have. So if you're under budgeted, you're not going to be able to build a lot. If you're budgeted correctly, then you would be able to build whatever you need. Along with building comes planning. In most instances, you have to know what's not only coming next month or next year, you would need to know what's coming 5, 10, 20 years down the line. A lot of cities have city plans. Some of them start out with a 10-year plan. I know some cities in northern New Jersey right now have a 2030 plan. And for the investors that are smart, they would look at these plans and they would see what's coming to the area as opposed to just building what they would like to see in the area. So capital is one aspect, planning is another, and then knowing your audience with who you're building for would pretty much complete that circle. So if you're able to understand that, and I was only able to do that throughout my years in real estate. I was a realtor, I was a lender, and now I'm a developer. So if I'm able to understand just a little bit of every one of those sectors, I feel like I would be able to offer, well, in an area, my skill set. So understanding each aspect from capital to planning to knowing your audience, that's how I feel like all of that comes together as it relates to building your next city or your next iteration of what you would like your town or village to be.
Any questions from the audience?
Okay,
And so all of my questions are going to be based on that concept.
sure.
Yeah, so up on the mezzanine, we have FFF 3D printing, and all of my questions are going to be in that context.
Sure.
So upstairs, a consideration we have is the bounding box of what job I can do and what job I have to do in parts. I'm curious, what's the bounding box of your setup?
We don't really have a bounding box per se. I will have Islam expand on that a little bit, but for right now, as it relates to when we're building, we can't exceed 2 stories. So that would be where we would stop. We can bring the machine upon the 2nd story and build a story from there onward, but the technology is just catching up to the times. So I would say in the next year or two, we'll have a machine where we won't be really limited. We'll be able to print not only the formwork, also the flooring, the roofing, and be able to just use that machine to just pretty much essentially build an entire house on the lot, as opposed to it being transported.
From a technical level, I would love if you elaborate on some of those limitations,
Sure.
On what is restricting access beyond the second floor, and what you're hoping to see in technology that will raise those ceilings.
Okay, sure. Would you like to?
Yeah, so you're limited by the equipment. So we actually don't print. We have two systems. One is the gantry system, similar to the machine you have. So you actually print within, or you have robotic arm, which you print away from your printer. So we don't have limitation on the size if you are using the robotic arm, because you can still allocate it around the print volume. We have limitation on the reach of the arm, the height of the arm, and also how quick you can print those structures. So as we evolve and robotics evolve, we will reach that.
Thank you. I have a follow-up question while I have the mic.
Sure.
So one of the abilities that is afforded to us from additive manufacturing is conversations about infill and conversations about composite, and specifically the void spaces to make things more lightweight, which is all relevant when I'm doing portable structures or I'm mass producing like vehicles.
Yes.
But now when you're designing something that's meant to withstand the test of time, so I wonder how you've repurposed that consideration in your designs. Are you talking about infill? Are you talking about composites? Are you talking about hollow spaces?
Yes. So the hollow spaces will definitely be there because that's how we're going to run all of our conduit. So as we build from the ground up, we do have hollow spaces that we can run conduit through, that we can do infill, that we can do your layers. Everything will be there. So all of that is thought about through the CAD drawings before we actually get to building. So yes.
I will answer this during my presentation. So
Thank you for your time.
hang tight.
I didn't want to take away
Hang
from this.
tight, you know. So we're gonna manage the question Q&A here with first part one is a problem. We will also cover part two, which is the solution. After that, we're gonna cover questions for proof, acceleration, and the future beyond Earth. So the first question on the problem will be, why is the way we build today's struggle to meet the demand of affordability, speed, labor shortages, and climate resilience?
Okay, so that's a compounded question.
Yeah.
So as it relates to the struggles that we're having today, we're having a struggle replacing people in the marketplace. A lot of younger people aren't getting into construction the way that they used to in the past. Construction has become quite labor intensive, which isn't inviting to some. The prices have been going up, as you know, all around us. And inflation, supply chains, things of that nature, all have had an asymmetrical effect on how we build and also our pricing. So we've been building the same way within the last about 150 years or so, and there needs to be new innovation around to help to support that. With that being said, if we're able to build quicker, more efficiently, and not cut the quality, we would be able to bring a lot more homes into inventory. And if we scale that up, we can actually cut the cost as we're building. I do know that we've been through a rough election cycle, and everyone says, oh, well, affordability. How do we make things more cheaper? Well, now in today's time, you may be able to afford the mortgage, but you might not be able to afford the home. And those are two different prices. I'll expound a little bit further by saying if the mortgage is, let's say, $2,000, that's the cost of the mortgage, that's the home. Now, if you have bills that circulate around the house and you have to take from one to go to the other and you're not able to pay the mortgage, that now comes into the pricing of the house. So the only way to be able to make homes cheaper and more affordable would be to start at the build level. So if you're able to scale and we're able to build way more resilient structures, cheaper, we would only be spending and doing things once. You will cut the mitigation of your losses. Let's say if you're building a wood house now, Something happens, God forbid there's a fire, okay, that house is burnt down, you now may have to build that house over from scratch. If you're building and you're using 3D printed concrete, which is fire resilient, your home will suffer less damages than others. I'm not sure if you guys are familiar with the fires of California, but there were only 2 homes that were standing after all of that was burnt down. And all those homes were built utilizing concrete. So when you pay for something once, you won't have to pay for it. Well, in most instances, if we build something that's strong and you pay for it once, hopefully you won't have to pay for it twice. So affordability and being able to source materials that are recyclable will help to scale and make homes more affordable for people in your generation and those to come.
That's great. Following up question, what is broken in the traditional construction model? And why incremental improvement is not the solution?
So let's see here. So broken would be management, I would say. Education is another one. That's the biggest barrier. You have people who have developed and who've built homes for decades, and they do not know about the new technology that's coming ahead. So education is definitely the biggest barrier. Communication is another. To be able to communicate to your local and state municipalities that you have new tech that can help to come in to improve the workforce and also to create more jobs. Those are the discussions that I feel like we need to have to improve the next iteration of development and construction.
This is also tied to the previous question, is if we already know how to build, why delivering home is still slow, expensive, and risky?
So if we know, right now, like I'll go back to the regular development. So on average, it takes about 12 months for you to build a structure. Throughout that 12 months, you have site visits, you have zoning, you have a lot of things inspections that will come in and that will hold up the process. Now, when we're building with a machine, we're able to build down to the exact millimeter. So there's no overage, there's no waste. You're able to build more faster and more efficient. So on average, if you're using a traditional build, which is 0 to 12 months, you would be able to cut that down, let's say, to half the time, maybe even a third, utilizing 3D printing. So with that being said, as opposed to your inspector coming out 8 months down the line just to tell you that you made mistakes and you have to do it over again, we're calling him in 8 days after we start. And throughout that process, you have something going on in the background called carrying cost. So let's say Islam lends me $100,000 to build a home over the course of a year, and I'm able to build a couple of homes over the course of a year. I would have paid him back $100,000 3 times over the course that it may take Thomas to do and complete one home. So with that being said, you're able to recycle the funds a little bit faster. The investor gets paid back much faster. You're able to bring homes to the market a lot faster than your traditional builds, and you would actually be able to have that asset start income producing right away.
Sounds good. So any questions from you guys on the problem? Go ahead.
What kind of exit strategies are you using after you're done with the project?
So you mean as from an investor standpoint or developer? So from a developer's perspective, the way that I would envision it is, like, what's your name? Esteban? Okay, so Esteban, you would probably give me a call or send me an email. You'd say, hey, look, Justin, I want to build a house, right? Could you build it for me? I would say, all right, cool, Esteban, send me your blueprints. You send me your blueprints. I would look to see what type of machine that I would use for your project. I would call you with an estimate for what the price would be. I would give you a turnaround time for what it would take for me to build it. Let's say if it's 2 to 3 months, I would come in. Once your foundation is already set in, I would bring the machine to the site. I would pretty much build your home or your structure for you on site. And then as soon as that's done, it would probably take me about, well, depending on your project. As soon as that's done, then I would have the exit strategy from there. So what I am is a print and play guy. You send me your blueprints, I show up, I print, and then I exit. But let's say if you're a big developer and you're building, let's say, 25 homes or more, now my exit strategy is a little bit different because it's more intense. As opposed to one machine, I may show up with 4 machines. I may have them all working simultaneously with one another, building 4 structures at a time. So my exit strategy is dependent upon the project, and it fluctuates.
One moment. Here you go.
Sure.
Just a quick question.
Sure.
Why do you feel that concrete printing is more affordable than other strategies that are in place? Let's say mass production, mass customization. We know that cars and pretty much everything else is achieved through those techniques. And this also in the context of time. If you have a machine produces, let's say, 3, 4, 5 houses a year. To produce 1 million houses a year, you would need 250,000 machines, or maybe 200,000 machines. If in a factory, I can have much fewer machines to produce parts and elements for the 1 million houses. So I'm just wondering, how do you place it in? Because for me, 3D printing of the house is still traditional building, is with a different tool. It's not really changing mindset that it's like, boxable mask at some point was living in on his in Texas. This $50,000 house, very small, but it has all the precisions of making appliance or making a car. That's kind of my question.
Sure. Well, you said a lot, and I definitely commend you on that. As it relates to, I'm just trying to cycle back. You asked me why do I feel 3D printing is the best step forward. I guess it's interpretive to what your interests are. For me, I find it to be more freer than your traditional builds because we can do and think of things that you can't build traditionally just offhand. But as it relates to, Boxable and other companies who have come into the space, I think it's just specific to what you're into. I like the 3D printing aspect because, again, when I look at a project, I know exactly down to the millimeter exactly how much concrete I'm going to use. Whereas if you're looking at a traditional approach, there's 15% allocated into the budget just for overages for waste. So at that point, I'm coming in, let's say, about 10 to 8% cheaper because I don't have to worry about extra material that's not going to be used that I would have to pay for that would show up in the budget. As it relates to, let's say, a modular as opposed to your 3D printed, well, on the modular build, you would probably be building that in the factory. After that's done in the factory, you'd have to ship that to wherever your destination is. That's another cost as well, per mile, and actually other people that will be associated with the project. If I'm able to show up on your site, then I don't have to worry about bringing anything there. I actually bring the factory to your site, and I do everything on site there. Again, it's different ways to make cars. Tesla decided to go with batteries. Others decided to just stay hybrid or even stick with just gas. I guess it's just all depending on what your interests are and how you would like to apply yourself. But the real answer to your question, why I'm stuck on additive manufacturing is because when we go off-world, you won't be able to build in that environment. Hypothetically speaking, if we were to go to Mars and we needed to do a moon base, we can't just hop out on the moon and just start building right away with a hammer and all these other tools. You would have to exercise a machine in order to build in that environment. So I feel like this is the best way forward for right now.
Nothing also will prevent it to be 3D printed in a factory too, if you have the right equipment in the factory and use it. So,
You can do RAM earth, right? For the two-story building, you can do RAM earth, which is much easier than 3D printing. You know what I'm talking about, right? So, and we know that on Mars, you cannot use soil for 3D printing.
Right.
We already know this. We didn't know this 10 years ago, but now the tests come that it's not. So there may be some other technologies that we need, like maybe combination of RAM earth and so on, that start impacting way of things. Because I would say, yes, you save on some transportation, but you also have major expense on general conditions
Yes.
to set up your host project
Yes.
and things compared to like Suboxable, when you may impact the highway traffic at some point, but it's general conditions and all things are slightly, not even significantly less pronounced. Okay, thank you.
Sounds
welcome.
good. So let's move on part two, solutions. So the first question will be, what does it look like when 3D printing of concrete move from experimental prototype to real building?
So when it moves from an experiential set to real building, you're actually able to apply what you learn in the lab out into the real world. And when we're actually able to do that in the real world, we're able to take what we learn and apply it to the real world off-world, which leads back to the question that the gentleman was asking me earlier when we're building off-world. So in the lab, you're able to use your mind and get really creative. As Islam knows, he's down on that level of the additives and making sure that we have strong composites. So you're only as good as your material. Fortunately enough, I got one of the best material scientists here. So with that being said, I think that for right now, with what we have and what we're bringing to market, I think it's future-proof, if that answers your question.
That's great. So back to your question also, hybrid construction techniques. So 3D printing with another traditional trades, do you see that as a solution
Yes,
on the
yes,
stage?
yes. So that's a very important question. So as we look forward and we're looking at tech, we're not going to forget about things traditional. So let's talk about like a hybrid setup where, let's say if you wanted to build a home and you didn't want the whole entire house to be 3D printed, we can do that. We would essentially build the outer shell of the structure, that would be 3D printed, but on the inside, we would use the traditional wall system with lumber and things of that nature, so that way, as your family is growing, it'll be easy for you to knock down a wall and, make the house more usable at that point. If you make the whole entire structure 3D printed, it would be much harder for you to do that if you wanted to add on an addition. Same way, you'll be able to add a 3D printed wall to an already existing traditional wall. So these things can exist and coexist together. It's all depending on your actual structure and what it is that you're trying to build.
Great. Can you tell me the true value of 3D printing for developer, builders, and investors?
So from an investor standpoint, I feel as though you'll be able to control the capital much better than you would on a traditional set, because there's things that are allocated in a traditional build that aren't necessarily a good fit, don't fit well within the 3D printing side. So you'll be able to save money on that way. From a development standpoint, again, it opens up your creative eyes. Architects really like it because they can build things that haven't really been seen before. So that's a good selling point for newer homes that are coming in the market. And I'm sorry, the last one would be?
The investor, builders, and
So I mean, investors are always happy when you're able to pay them back a lot quicker. Builders are always happy when they're able to build quicker and they're able to sell the product right away. So it's a good trade-off for both parties to be able to utilize the tech to make their jobs much easier.
Can we add labor? Like what's the impact on labor?
So labor, I think labor will be improved twofold. One, you'll be able to get paid the same amount that you would before because you're working alongside the machine. But now with you working with the machine, there's less aches and pains on your actual body. My family have a lot of construction going on in my family. We're from the Caribbean, so being in construction is like your second job. You go to school and then you learn how to either lay tile or work with sheetrock or something like that. So, lugging sheetrock and big, large construction objects around, no one really wants to do that. As a kid, I didn't want to do that. That's why I didn't get into construction. I was lazy, I'm not gonna lie. So my innovation and my thoughts came out of laziness and not wanting to actually do the hard work. I wanted to come up with a better way to work more efficiently. So labor is something that Again, I think we are not trying to put people out of work. We just want to have you work alongside the machine and have the machine work for you as opposed to taking a long toll on your body. And I think that at the end of the day, at 8 hours, we all go home tired. If you can have less stress on your body and save some of that physicality for your family and to be able to enjoy yourself at the end of the day, that's what it's all about. We're in 2026 and we kind of got to act like we have the technology at our hands to do so.
Great. Any question, one or two questions on solutions?
Sure.
Evaluation, or would you say, I guess, like, if you were trying to do like comps for the property, would you look at the existing market, or would it be based on cost of development?
So I would look at the existing market. From a real estate background, obviously you can only sell, what the market is willing for, but when you're evaluating it from a lending standpoint, the valuation, I feel like the 3D printed homes would have a higher valuation than the traditional homes because we are building a better quality home for almost the same price. So there's certain insurance companies that would be willing to incentivize us because they know that our structure is way more resilient than the others. When you have a when you have a fire retardant property, seismic proof property, tornado proof property, it kind of mitigates the losses that you would have versus someone with a regular traditionally built home. They're going to incur all of those problems that may arise. So yes, I feel like valuation-wise, if I had to say, I would say our homes are at least 10 to 15% more valuable than your traditional, and I'm just being conservative on that sake.
That makes a lot of sense. Also, for people who do like rentals, do you think that the evaluation could also come from, say, like if you wanted to use like a DSCR loan?
Yes.
Like,
You're speaking my language.
It seems pretty attractive for a landlord because you basically have an indestructible block.
Yes.
So I know, like, if I wanted to do, say, for example, like Section 8, like the actual cost of development, is there a big difference between standard construction and this method? Is there like a big delta there?
So the difference price-wise, you're probably looking at anywhere from 10 to 20%, roughly, that you would be able to save. But where things really come into play is the time. So you mentioned DSCR. You also mentioned rental markets. So there are loans out there right now that if you're a developer that you can get to build small communities to be able to rent right away. It's called build to rent. So in my mind, I look to partner with those entities to build a neighborhood or a rental environment for them a lot quicker than your traditional would. So typically they would reach out to someone in the area who can build, let's say, a house in roughly, let's say, 9 months or so. If I'm able to do that in a third of the time, then I can bring 3 homes to the market quicker than the traditional would. So yes, a DSCR or an investor would definitely come to me because I can say for the same price, I can do 3 times the work versus waiting for the traditional to finish for the one. So it's all about making sure that you're bringing quality and savings to the investor, also a speed of time, so that way they can sell that product or rent it way more efficiently and quicker than their counterparts.
Thank you.
Okay. One more question here.
Hi. So this is to a point on you mentioned that it was flame-proof, flame
Yes,
retardant.
yes.
But more, you said California fires. On the East Coast, like New Jersey, Florida, we're more susceptible to hurricanes.
Yes.
Are there plans to make this material more water resistant?
Absolutely. So out the gate, it is hurricane-proof, tornado-proof, seismic-proof, pest retardant, fire retardant. Those are your main components of 3D printing. And we have scientists and people that are coming, like Islam himself, who can actually further foolproof that with additives and mixtures. So yes, all of those things are thought about before we even get to the actual build. And that's why I'm so excited about it, because my family's from the Caribbean, Antigua and Barbuda to be exact. So sometimes when I would go down after a hurricane, I would see the destruction. Well, if we start to build in a more smarter way, we won't have to endure a lot of the discrepancies that come along with hurricanes and power outages and things of that nature. So again, stupidity and intelligence can't occupy the same space unless you're in Congress. But with that being said, we kind of just want to use all of the technology and all of the tech that we have now and streamline it and make it affordable so that way, you know, when you guys start to have kids, it's more affordable for that generation to come.
Sounds great. So we're going to move to the next slide. Proof and acceleration. So as you know, currently Walmart printed the first 3D printed Walmart was 8,000 square footage. What does building the largest 3D printed structure in the US reveal about the market readiness and institutional trust?
So going back, so I'm not sure if are you guys familiar with the 3D printed Walmart? Anybody? So it was a 8,000 square foot build. Good company, Alquist. They built, and they actually got contracted to build some more. I'll piggyback off of the Walmart to say we all know data centers and everything are being built. So 3D printing would be a great way to start to get in building those types of centers where you need to scale and you need to have speed for your build right away. So for the institutions that are out there, I feel as though they're way more trustworthy with us now. They kind of know what the ins and outs are. There have been some homes that have been built. And with us building the largest structure in the country, I want to say maybe the world, I think that it will be a great template for us to really showcase what we can do. Within that structure, we will be not only working with concrete, we'll be working with other additives as well. And it's definitely going to be an anchor for this region, for the northeastern region. So it'll be something that you guys can get out to. I can't speak much about it right now. We're kind of under like a gag order, but you will see some things coming in due time in the media.
Sounds great. Last question in this section is how can public-private partnership between private company, state, local government, accelerate adoption, and also reduce risk?
So does anybody know what a public-private partnership is? Cool. So that's a partnership where you have an entity such as myself, a regular company, wanting to partner with government to streamline business and do it in a more efficient way. That relationship, I think, needs to be had a lot more with a lot of businesses. People really need to understand how the government works and how they can actually be beneficial for you. There's urban opportunity zones that if you're able to go in and purchase a nice lot or an acre of land that would be afforded to you at a cheaper price. And if you're able to build on that land, then obviously you would be able to sell at a quicker selling point than others. If you're buying at the height of the market, then you would have to incur paying the highest price that you possibly would for such said land. Then you would have to go build on that land. Now you're already, up over where you might have wanted to invest it versus purchasing at a lower level. So having those relationships, I feel, is important. I started out by talking to local and state municipalities, understanding what their needs are, seeing how I can help them. The good part about 3D printing is that it's not only just subjugated to homes, we can actually build infrastructure as well. So anything as it relates to concrete, we can build. We're talking about bridges, we're talking about outdoor furniture, parks, pools, skate parks. So all of those are things that could be an added benefit along with the homes as well for the communities. And if you know what is coming in a community, you'll be able to support that community by bringing your skill set. So I think public-private relationships are great. I have one now and been fortunate enough to have one with Rowan, where a private company is working with a public institution to help to bring forward the next iteration of building and workforce and training.
Great. So next slide. So beyond Earth, right? I think you touched most of the questions here, but if you briefly want to answer the question, why is suitable for beyond Earth construction?
So as we all know, the next on the horizon is the moon, then Mars. With all of the, I would say, elements that are out there, we haven't really been able to explore outside of the Earth per se. with me being a huge nerd, just growing up as a kid, I would look at all of these different cartoons and I would see all these different structures of things being built, not only on the moon, but just off-world. And I would always sit and think, okay, if we were to go out there, how would we build? How would we be able to create a habitat in that environment? And with doing so, it creates a whole different way of thinking. If we're able to take our species off-world, that's something that hasn't been done in anyone's lifetime, even previously, that we may have known of. So I kind of want to be a part of that if that is the next iteration of how we're going to evolve as a species. If I could lay the groundwork to help the next generation to be able to do so, I think that would be awesome. There's a lot of, again, different elements, different components that if we're able to source from other planets or either entities, if you will, if we're able to extract those elements, we may be able to bring back things to the earth and have more efficiencies with how we're able to live here. The only way that we can do that in a safe manner would be to create safe habitats in those environments where we can live and we can thrive. And with that being said, going off-world, we have SpaceX, we have Blue Origin, all of these companies that are going out and setting up for the space race. I think that it's important for us to know what's out there, to learn about it, to see what we can do to be a part of that, to help to profit from that, and also bring that knowledge back home to humanity.
That's great. So the next question is, what can off-planet construction teach us about resilience, efficiency, sustainability in extreme environments?
So, in extreme environments, we know if we're able to survive there, we'll be able to thrive, we'll be able to live long. I don't think that we know what the habitat of Mars is like. We don't know what we'd be able to incur, but we do know if we're able to build a strong, solid structure to be able to observe what's going on in and around, we'll be able to have some time there to really understand it and really digest it and really be able to send that information back home. So again, I think safety is the best way. Right now, we test very rigorously. There's several different companies that will go out and build in the Arctic region. You have certain companies that will go out and build in the desert, build in the most extreme conditions just to be able to make it simple for us when it's our turn to build. And the only way that you'll be able to extract that knowledge is by actually doing it. So in the lab, sometimes we make it much more extreme, so that way we can see how we can test ourselves. There's ways where we can actually print underwater to come that I'm sure Islam will talk about later. So it's about, just doing things that haven't been done before. It kind of teaches us how to grow and how to live. And our mind and our thoughts are only going to take us as far as we go. And in my mind, I would like to be limitless. I wouldn't want anything to hold anyone back. So if we can develop, technology to push us forward into a whole other realm of thinking, I kind of think that's why we all go to school. So I welcome that, and I would love to push it forward.
Sounds good. I think you also answered last question too. So any additional questions from the audience?
Hi. You talked about building off-world and architects also being able to design any kind of shape. What are some kind of, when we talk about the machine itself, the actual 3D printer, what are some kind of engineering challenges that you've been facing, say, pushing the technology forward? Because right now you mentioned that you're limited to building 2 stories. You could put the machine on top if you wanted, but that's something else. Moving forward and, say, thinking about the future, what are some of the changes or what are some of the ways that the machine itself would change or would look to accommodate those different either harsher environments or, I guess, greater customization within the structures? Because with this layer-by-layer construction, I'm curious about what are kind of some of the architectural limitations, talking about overhangs. We already know with 3D printers themselves, when you have to build a strong enough overhang, you need some sort of structures that hold it up.
Like lintel?
Exactly. So considering the concrete, when it's printed, as at least I'm assuming, comes out in a liquid form, what are those challenges that you guys face in that?
Would you like to?
I think if you hold for 1 minute for my presentation, you will find the answers. So,
Absolutely.
listen, okay, maybe I'll switch to, thank you very much, Justin, and
Absolutely.
I'll switch to my presentation. I'll try to make it light, not a super scientific, but let's see. Okay. If you want to find me, it's like not in the size me. So I'd love to move around always, so it's too much. So yeah, enough introduction for us. Let's go to the first slide. So in the first slide, I always start asking questions. What's the difference between what you see on the left side, on the right side? Left side is 1950, right side is 21st century. Nothing, black and white, right? So this is how we construct in concrete. On 1950, we still have formwork, we still reinforcement, bunch of worker around, no hard hats, unfortunately, and barrel that fill the concrete and some vibrators. So basically, we're doing the same thing, but I think over a span of what, 70 years, 75 years? And if you see other industry, in 75 years, you'll see a difference, right? So to classify construction, we classify at Rowan into 3 major areas. One is conventional construction. You form, you place reinforcement and cast. What we have right now, I call it hybrid construction, because most of the company, what they do is they print the formwork, and after it's cured, in 7 days, they place reinforcement and cast. So it's way between the two. What we try to do at Rowan, we're trying to make it as one process. So we call it additive construction with optimization. If you are familiar with concrete, I see a lot of CIM students here. Concrete is good in what? Compression, weaken tension. That's why we use reinforcement. But back in the day, they didn't find a way to reinforce blocks and concrete, so they use arch structures. So can we bring back those compression-only structures, given that we have freedom to print now without formwork? If you want a formwork, this structure is going to be very costly. So with optimization, you can lead to that, and you can also invent new ways for reinforcing concrete printed structures. So just to highlight quickly here, concrete by nature, we make it flowable with good slump for 2 reasons. First of all, to fill formworks and encapsulate reinforcement. So as you can see here, now it's changing the way the concrete behave. We cannot have it flowable because it will not stack layer by layer. We also cannot make it super stiff because it will not pump. So we need a balance between pumping and extrusion. So basically what we need to do is actually a new material. Look, it could be considered a new material. So challenges included, first, as you print, you will see a lot of challenges will building up. So you'll see buckling and failures and cracks, et cetera, et cetera. You need to mitigate that. Second is the entire structure is exposed to environment, so you'll have a lot of early age challenges and shrinkage that you need to compensate for. Oh my God, reinforcement. How are you going to add reinforcement as you print? And a lot of big challenges here, and the easy way, or call it easy and lazy way, is to print a shell, ask someone to place reinforcement and cast later. And the material itself, concrete as a material is anisotropy material, meaning that it is in all directions, should have different properties, but within casting, we eliminate a lot of that to a degree of like 95%, you can consider it isotropic. But when you lay it layer by layer, the properties now change based on the direction of loading. So the material became anisotropic with issues interlayer bond. So at Rowan, our lab called ARC Lab, Additive Robotic Construction Laboratory, we focus on 2 areas. One is concrete additive construction, one is metal additive manufacturing. Today I will not cover metal. I know you have a facility here for metal, but we focus on optimization, how we can create creative structures that mimic how our joint works in terms of dissipation itself, how can we use low carbon materials plus locally sourced material, how we invent the new reinforcement techniques, and also create multifunctional structures. So at Rowan, all the material we use is created by us. We are locally sourcing the material 20 miles away from Rowan. So as you can see here, a lot of difference between casting concrete and printing concrete. I know from construction standpoint, what's the major properties that you worry about in concrete when you have casting. It's compressive strength, right? But on site, the major one is a slump, how much the concrete will slump down. In 3D printing, you have to fulfill so many stuff. First is how far the flow, if you are using flow table, how many minutes to set. Also, the printer itself or robotic arm interact with the material. So how fast can I extrude? How fast can I print, et cetera, et cetera. And at the finish, you need to make sure that layers are fused well, you achieve the compressive strength, and also you need to know how far my model was printed, as that's why you can use LiDAR scanning, et cetera. So this is what we have at Rowan right now. I think you guys have printers soon from whatever company name, right? So what we have here is a robotic arm on a track. It can enclose itself by printing enclosure, but in one side you can print 20 feet by 7 feet by 7 feet. 20 feet is the length, 7 feet is height, and 7 feet of arm reach. We can print 1 to 4 inches per second. The printer can spin around itself 360. We have two systems. The first one is open system with mixing, pumping, and filling the agar to print. I'm from Egypt, so I print all days pyramids. And closed system, we can have a syringe tube to print smaller structures. So here are the three systems that we have at Rowan, a small syringe tube. This is the first print we did 3 years ago on the material. We print also with the agar system, and we print also direct to the nozzles. In the agar, it gives us more freedom on controlling the extrusion rate and speeds. So yeah, it's the same material with a little bit different iteration in order to use it through different systems. And as I mentioned, it's locally sourced and developed by us. So we also print using fibers in the mix, so steel fibers. We were successful in printing with up to 12 millimeter steel fiber, half inch, and up to 1% by volume. As you can see here, the material is extruded with fibers within the matrix. Here is how we printed the pyramids here. As you can see here, a slope of 26 degrees from the vertical position without the need of any accelerant. Our mix actually does not have accelerant in it, so it's called 1K. We don't add any accelerants. And here is a snapshot from printing the pyramid here. We printed this one, okay, material has good buildability and can sustain the slope, 26 degrees, but still mild slope, it's not heavy slope. Back to your question on the overhangs. So we start to say, okay, let's print with different slopes. So this is like a pier for bridges. You can see here, we start from almost zero slope and incrementally increasing the slopes. And quality-wise, I feel like this was like a year and a half ago, quality was good that time and still getting better and better. But what if we want to exceed that? So what if we just print until we fail? So as you can see here, we print with extreme slopes, very small, 2x2 base and maybe 2 feet high. As you can see here, almost printing in the air because losing the seat. This is actually a problem of the modeling itself because as you go in extreme slopes, you're shifting the layers. And there's a little fight here, right, in the slope, but didn't collapse completely, just partial collapse. That gives you the definition on limitation of your material in printing the slope. In the market, they barely exceed 25 degree slope from vertical position. Our material is good at up to 60 degree. And with fiber, we reach 70 degree. So material itself play big roles. We also have a very exciting project, printing underwater. So we actually put the nozzle underwater and print. Not because we want to make more troubles, like people cannot even print in air when printing underwater and flexing. No, we were trying to use liquid, and water is one of them, to actually help us in completing the slope. And we figure out, as cementitious material, you will wash out in water, so we actually make the material weaker, structure weaker. But as you can see here, we finally was able to print structures underwater with almost, I would say, minimal washout. As clear as you can see the water. This is not Photoshop, it's just extruding underwater. We have a student working with me on this one, and he's very good in innovation in materials, and I challenged him, he cannot get his PhD before he actually drink from the water after he prints. Let me just safe water, keep the water safe. I'm just kidding, I'm not gonna do it. So back to the reinforcement issue. If you're familiar with concrete structures, as I mentioned, concrete strong in compression, bad in tension. That's why we place reinforcement in the tension side. In the compression side, we just put minimum reinforcement to have the cage. And we have closely placed stirrups here and there, and stirrup in the middle to carry the shear. So what we're trying to do here is like, should I print the formwork and add the stirrups and rebar and cast? It's a joke, right? Just do a different formwork. Just use wood formwork, or as we do in construction. What we try to do here as a concept, if you have a beam like that and you have uniform load, if you do some analysis, you will see that there is trajectory lines, which is called the principal stresses, that create kind of an arch in compression and an opposite arch in tension, right? So what we came up with this idea is like, can I actually print the arch in concrete and reinforce the tension the way as I build it? So we came out with this honeycomb design. So we printed, as a concept, we print hexagonal cells, and after that, as you print, you can have a robotic arm that places reinforcement. We can have two designs. One is reinforcement, regular reinforcement, a cable, but we prefer the cable because the cable actually could exactly match the tension line. And once you match the tension line, you don't need stirrups, you don't need any additional reinforcement. So what we have done here is a quick video of us printing those hexagonal cells, student placing it themselves, but in future, this will be a robotic arm placing reinforcement. And as you print, you keep printing and keep placing reinforcement as you need. And at the end, what you do is you can, in process, change the material rheology and fill those pockets as needed. So in compression, you can fill it. In tension, also you can fill it to protect reinforcement. If you have stainless steel reinforcement, you can actually keep it open. And some areas you can leave it open if they have zero stresses. So you actually can lighten the weight of the structure by design, right? And this is what's called topology optimization. You place the reinforcement where it's needed. So that said, let's go for experimental testing. So we printed this beam, we tested at Lehigh University, and we reach out, it looks bad if you break it, but you break it until it fails. This is how we do in structural engineering. And you can see here a very nice steady increase on the strength, and you load it. And those openings can actually serve as utility lines, or in bridges, you can actually use that to dissipate waves, loading, and lateral loading. In columns, can we reinforce? In reality, what we do, if you go to construction site, you have all this formwork and spiral, longitudinal reinforcement, etc. We came up with similar reinforcement way for concrete printed structures. So basically, you print the majority of the structure, you leave cavities for if you use post-tension or rebar, and in process, you can start filling them So here is a example of a small scale column where you can print the column, leaving cavity for rebar, and after you finish, you can fill the reinforcement, place the reinforcement and cast the cavities. We are not incorporating what is called transfer reinforcement or the confinement that can be done with other material. I have a video here, but it's not running. But can you run the video from your side? I think the middle one is the big, okay, back here. I think this is a video. I'm not sure if it's still there or not, but this material is sprayable polymers that can confine the column and substitute stirrups. So this is the process. You print majority of the column. Hopefully, as you finish the process, you place reinforcement and grout it. You spray, and you have different type of columns that we tested, also at Lehigh University, and we came up with understanding the failure mechanism and all those different columns, and as it break, how it can create stresses, etc., etc. I will not dive deep dive here on the result, but this is what we are looking for. And for sure, I need to add Justin here to additional collaboration. And this is what we work with, who we work with, Army Corps of Engineering, ISC, and industry partner, also including NIST and Department of Education. So nothing I can do alone. I actually am the one that maybe do the least amount of work. All goes to the student behind the lab, 2 years and a half in operation, and I think we are doing a decent job in this area. So if you have any question, I'll be happy to receive.
Islam? Let me see the. Yeah. I think there might be one after that. I'm going to show some videos.
Questions so far? Sure.
Hi. So with the onset of new manufacturing technology, I feel like there's a phase where you, to make it more palatable, you emulate traditional techniques to make it seamless. But then there comes a phase where you graduate from that, and then you start to show off what now this technology allows and different ways to design. And in the case of our tabletop additive, we're encouraging students to push the boundaries of what their geometries can form. And I'm not really sure how to phrase the scope of the question because you've already talked about what's happening internally. But what I'm trying to get at is from an architect's standpoint, so someone who's commissioned you for their job, how do you train the designers to now think beyond the squares and rectangles that our homes have been? What are some of the capabilities that they really need to capitalize on that maybe we haven't begun to think about? So how would you educate the designers to design in ways that graduates from traditional manufacturing?
It's a long process. So most of the work done now is exactly emulating the existing practice by either printing formwork and casting concrete. It's a long route because basically as structural engineer, we have to certify the building for safety. We have to sign, and there is a reviewer that has to sign, and the QA has to sign also. So if someone is not familiar with technology, it's like what described, no, go and cast concrete, right? So it's a long shot, and also the coded standards we have to follow strictly. And we don't have coding standard in this technology, so it has to be by testing. One thing is very challenging for me is I actually ask my student to not think in conventional ways, because this technology is not meant to print formwork. You make it expensive, you buy expensive equipment that can be another way for forming is more efficient. What we're trying to say is, if you ask you a question, what is the benefit of any additive manufacturing technology, you'll answer two things: customization and optimization. So in order to reach that in construction, you have to achieve custom designs and optimized design. One thing that is also challenging is we have every building or any structures is unique. we don't produce 1,000 Kias, right? Every single building is different. Second is, the technology entails a lot of good opportunities for optimization, lightweighting, et cetera, and the way we have it right now is actually opposite of that. So I always use this example. If I give you a Ferrari, will you be happy or not? If I give you a Ferrari or whatever, you'll be happy, right, having Ferrari, right? But I tell you, like, no, one condition, don't speed up beyond 25 miles per hour. You'll be upset. It's like, no, take it off, right? So this is what we're doing right now in 3D printing concrete. We have a nice robotic arm and just printing lines. So, and we're very incrementally slow in implementing technology. I showed you the first slide, because 70 years the equipment changed to be a casting truck or concrete truck. So as we go, we swim on opposite of the current, but we'll see how it goes, So it's very incremental. Yeah, go ahead.
When we set up our prints upstairs, one of the considerations we have is, do we have enough filament? So where's the material coming from and how is it stored? And when I run out, I just put on another spool. So I know the volume of what I need before I have to re-up. And so I'm curious, are you guys using hoppers? Are you piping the material? What's the refill procedure?
So we do similar stuff, right? When you print the structure, you have to calculate the volume of the material. So ahead of time, you have to know exactly how much, not in filament, but in cubic yards. And we have to offset that because you also need to prime the system. Prime the system means that you will have the pump, all the hoses, up to the hopper or the extruder has to be primed, filled, before even you start printing. And you also need to have extra percentage of material to cover any stoppage in between. So you have to do all this calculation ahead of time, and also the cleanup, et cetera, process. You don't have much cleanup when you're printing. We have a lot of cleanup to be done in this process. So yeah, we do a lot of that similar to you, but we have to sort that ahead of time. We cannot go to the job site and say, okay, we are short by 200 cubic yard. Let's figure out when we will get them. Okay, so similar way, instead of millimeters, inches, feet, and meters. Yeah.
Thank you. And the final question I have is regarding the salinity of the water solution, because projecting applications of when you have it down,
Yes.
How that's going to impact if you're going to do builds offshore.
Yeah, so this is for underwater printing, right? So we are taking step by step. So we are using tap water for now for printing underwater to understand how the material interacts with water. We actually, the one reason we trying to do this research because there was a research proposal a year ago by DARPA. I'm not sure if you guys are familiar with DARPA or not, but it's advanced research project for defense. And the challenge was they want us to send the printer to the ocean and use 90% of the material from ocean to print with. So you use instant ocean, salt water, you use settlement, use sand from the ocean to build up underwater. So under salinity of the water, if you use it in the mixer, it will accelerate the reaction, which actually help you sometimes and hurt you sometimes. And surrounding material with also salt water will accelerate that too. We are just starting to substitute our water-wise instant ocean, so maybe next year when they come here, maybe I'll give you some results or in papers. Thanks. Any other questions?
Yeah. Oh. I'll do one and then we'll go over there. I have a little bit of a complicated question, I think. I have designed and been the general contractor for a couple houses myself, and there's there's a lot of back and forth that goes on when you decide, well, what kind of foundation you're going to do, what kind of construction are you going to do, and there's a lot of products that come on the market over years that aid in your construction and timelines and things like that. And so the last few properties we built, we've used precast concrete for the foundation structures. And when you're in this phase of construction, you get a benefit from, for example, the walls being open for several weeks when electric can be run, MEP can be run, all these things can be done. And when I teach my students about product development and product life cycle and things like that, we have these new technologies that are developed, and we know how easy it is to prototype something, and then prototypes go relatively fast, and then that last step where you go from prototype to market ready is often many times longer than the foundational technology development.
Yes.
So where are we when it comes to this kind of 3D printing? Where are we in the fact of if you 3D print a house, there are so many things that go on the walls, so many construction codes, so many different trades that need to go in there and pull cable and run wires and put ductwork in and all those things. So where are we in terms of solving those foundational construction problems for modern 3D printed construction?
Yeah, I can answer and I can give it to Justin after that. So something I didn't mention during my presentation is we do not only do additive, we also do subtractive, meaning that you can print an early age of the material when it's reached a certain strength. You can actually start subtracting from it, creating opening, conduits, etc., etc. So it's not like you have to wait until it cure after the drill through, or even drilling through early. You have a window where you will not damage the structure if you start slicing out of it. I wish I have the video for it, but I have my student always printing instruction and with drills go through and drill early age in different times. That could be one solution for Induit. My vision is if you have, it depends on this also job site. If you have a remote area when you print those houses or army application, etc., it's really need to use local source material and a printer to print those structures. You can actually print foundation near site and place it. So it's like prefab style. You can also print walls in place. You can print wall horizontally and rotate it. You can print roofs off-site and place it. So there is a lot of options, but to get it to the market, I think the strategy now is just to make it shell and cast later concrete. But I think the potential for this one is huge and it takes time. So Justin, do you have any questions?
Yeah, so to add on to that, I've actually been on work sites where we are running conduit right after, well, not right after, but maybe like a day or two after, and with the cavities being open, we actually expedite the build process because the electricians and the plumbers, they're coming out a lot quicker to an open space that they can actually work with. We do have programs that when we are taking into account the build, we know exactly where the water and the electrical will be ran. So we'll make those cutouts to make it more accessible for the plumbers and also the electricians. So everything is about, just being forward thinking about it. We have the AI to do a lot of the work for us. So it's just following that and just expediting the process overall. Yes. Mm-hmm, mm-hmm.
Yeah.
Yep.
Question?
I had like a two-part question.
Sure.
My first question would be, what would determine the thickness of your concrete set wall, being it based on the location? And further, how can you consider thermal conductivity? Just because we are taking it as a hollow cut section, if you're saying that. And my question to the next part is, how would that increase your entire cost of construction? And again, would it really depend on the location, whether, just like to the surrounding? Yeah.
So the first part of the question is what they determine the thickness of your structures. It depends on, similar to any design. In the wood construction or concrete, you design weight. You find that your loads, dead load, live loads. If you are in zones with snow and cold weather, you have to include the snow weight and loads. So that would be structure consideration that is in any structures. We use the material strength and the loads to determine the thickness. Our material can do up to 9 to 10 KSI, 10,000 pounds. 10,000 PSI, pound per square inch. So actually we can reach thinner, but when you go thinner, you need to be careful because you are now cylinder, so during construction, you may buckle away or even during the loading, so there is a balance and structural analysis need to be done. You're right, we have a lot of maybe cavities and opening on the walls that can be filled with insulation, insulative material. Your wood will not also provide any thermal benefit unless it's insulated. So
Yes, then there would be a fluctuation of cost compared to your traditional house.
it has also
construction.
insulation.
And-
It has insulation too.
Yeah.
Yeah. The good news that what you can do is you can actually have thermal breaks and other technology that can make the structure more efficient from energy standpoint. It's a whole perspective of design that includes trade, engineering, and also power efficiency.
And then just to go back to your first question, we just take into account where the actual structure is going to be.
Yeah.
So if you're building in Florida, we need to make sure that it's resilient for that neck of the wood.
Yes.
If you're building in a cold climate, we want to make sure that the walls are thick enough to retain the heat after it's already been heated. So yeah, we take into account your environment and we build according to such. We just want to make sure that the structure is resilient no matter what environment that it's in. And that really probably comes down to the mix as well.
Also, when it comes to 3D printing, I wanted to know, like, how do you determine your size of the nozzle that you're going to 3D print, and what all additives are added to give out kind of like a perfect solution to your entire mix?
So you can print structure, like you can print one wall that is maybe like 3-inch thickness with any type of nozzle. The problem will be how many beads you stack side by side. And if you have more beads, that means that you will have longer print time because you have to go back and forth in the wall, let me say 3 times. So most of the printers has like adaptive way to change nozzle sizes. It's always better to use 1 to 2 inches because this is what is common in construction. If you start using 8 millimeter as I have here in the closed system, you'll take like maybe 3 times the construction time, so that's also a factor. And what second part was what?
My part was like, what's the ideal size?
Ideal size will be 1 to 2 inches to make it productive. In the additive, what you need to do is you, as I mentioned, you need to engineer a material that does not slump and does not clog. And there is a lot of additive in the market that can do that for you, and also you need to worry about shrinkage. So you engineer mixes. There is mixes in the market you can use, like a filament that you can buy in a pre-packed mix, or you can engineer your own using local source materials.
Yeah.
Sounds good.
Yep, sure.
So I'm an architecture grad student, so I have like quite some experience in terms of interior design as well. So what happens in terms of designing interiors? What are the flexibilities that 3D printing provides? Because if it is going to be a concrete wall, what's the tolerance of drilling something? And then if something cracks up or like if there is a breakage that happens, how do we address that?
Yeah. So there's smaller machines that you can, that certain companies will send with you. So you'd be able to make the patches provided that there's any cracks or anything of that nature. So there is a little bit of a window for you to reach out to us where we can come in and make those repairs for you if need be with a much smaller machine. But as it relates to your walling and you being an architect, I'll show you in a slide afterwards. Again, it just creates, it gives you the ability to use your creativity to your wildest imaginations in terms of patterns, colors, formations. If I wanted to, I can probably take a picture of your face and etch it into the wall design-wise, whereas you would have to probably pay an artist to come in and chisel that. That's another fee as well. So you're an architect. You don't want to be limited to anything. You want to be able to build whatever you want. So you're, in your mind, and you could correct me if I'm wrong, you would come up with a drawing and you would partner with your best friend who would be the engineer and say, this is my vision, how do I build this? He's going to tell you there you go. He's going to tell you exactly what you need, the strengths and everything of that nature to help to bring your design to fruition. And that's what we want. We want you to be able to live in, like at the end of the day, we're all going to end up in a box, unfortunately. But we shouldn't have to live in a box all day, every day. I mean, there should be some sort of individuality to what it is that you have, some sort of customization. And again, you know, we're being asked to pay in the state of New Jersey anywhere from $400,000 to $1 million for a home. Most of those homes have been built in the 60s, 70s, 80s. So why is it that I'm paying more for an inferior home when I can build a home that is maybe 10 to 20% cheaper than what's being asked, and it can be representative of what I would want, as opposed to going in and paying hundreds of thousands of dollars for someone else's idea. So that's the way I think. I could be wrong, but I kind of feel like, we all need the freedom to express ourselves and be creative and live that way, should we see it.
Also, what is the edge that 3D printing has when compared to a CMU construction? Because that's something, the same material and then the same amount of the reinforcement that's gonna give, but it's pre-moduled. So it's something similar, but what is the edge that 3D printing has towards that?
The edge?
Yeah.
So the edge would be timing. You would be able to I would be able to actually build what it is that you're designed down to the millimeter of the preciseness of what's there. I could use minimal materials to do that, whereas if you did it traditionally, it will take you much longer, resulting in you spending more money for the same structure.
Okay. And
One thing to add also is freedom of geometry, right? So CMUs will always limit you on the box, right?
Yeah.
So
and lastly,
I'm sorry. I'm glad you brought up CMU because what the machine is doing is mimicking CMU.
Yeah.
So just imagine if everyone in here had to lay blocks. That's going to be tiresome. If we had the machine to be able to do that, to mimic your design, now we can move more freely throughout the workplace.
And lastly, what about the joineries? Like when it comes to fixing windows and doors, what are the limitations that the market has in terms of 3D printing that has to offer?
I don't really think there's a limitation around that because as it comes to when you're building your windows and your doors and your framing, and it's going to take into account where your starts and stops are. We essentially, use traditional methods to seal all of those gaps, provided that there's anything there, and I'll actually be able to show you on a structure from the frame aspect of what that would look like. But there's really aren't any limitations in regards to that part, in my opinion.
Thank you.
Sorry.
All right. Let's have a big round of applause for our guests.
Thank you.
I'm sure they'll stick around for a few minutes
Absolutely.
for some questions, but we have to wrap up. Thank you very much.
Thank you.